pressure? Pressure means the force applied per unit area. If force is applied in a large area, then pressure will be less, and then pressure will be more. So pressure is directly proportional to force, and pressure is inversely proportional to area. So pressure depends on two things: force applied and the area the force is spread. So we have started and we have discussed, but again I'm recalling the pressure and what is the unit of pressure. So come to the first page, that is pressure. So we say that pressure is defined as the force spread per unit area, and pressure is equal to force oblique area. P is equal to F by A. Large area, low pressure. Small area, small pressure. So we have to learn, you have to learn these two things: large area, low pressure, and small area, high pressure. Now, we generally say that a small force, if is exerted on a very small area, then it will create a high pressure. But when a large force is acting on a large area, so pressure is directly proportional to force but is inversely proportional to area. So more area, less pressure; less area, more pressure. So this explains why we apply a force on the ground side of the nail. So it comes as a large pressure on the nail, and it gets embedded into the wall. Hence the pressure depends on two things: force applied and the area over which this force is spread out. SI unit of pressure is Pascal, PA. And I have already told you that Pascal was taken from the name from the scientist, French scientist called Blaise Pascal. So 1 Pascal is equal to 1 Newton per meter square. So 1 Pascal is equal to 1 Newton per meter square. So when a force of 1 Newton acts on an area of 1 meter square, exerted will be 1 Pascal. And if we have to say 1 kilopascal, then 1 kilopascal will be equal to 1000 Pascal. So 1 kilopascal is equal to 1000 Pascal. Here one example is given. Find the pressure exerted by a can of an aerated drink exerting a force of 3.5 Newton with area of contact as 5 into 10 to the power minus 3 meter square. So first of all, we see here the force. An area 5 into 10 to the power minus 3. So we can also change this as 5 into 10 to the power minus 3, that will be 1 divided 1000 meter square. Okay, now using is equal to force by the area, so we write what? P is equal to 3.5 divided 5 into 3, 10 to the power minus 3. So in this case, 5 into 5 into 10 to the power minus 3, it will go up. First we will cut this 7. So we will cut, again I am writing 3.5 divided 5 into 10 to the power minus 3. So what we will do, first we will cut this. So 0.7. So 0.7 into 10 to the power 3 will, when go up, it will form just 10 to the power 3. So 0.7 into 10 to the power 3 will be equal to how much? 10. So when we will cut it, it will change into 10 to the power 2. So the answer will be, answer will be 0.7 into 1000 divided, if you remove here and cut, answer will be 700 Pascal. 700 Pascal will be the answer. So in this way we will calculate the answer. So pressure is here 700 Pascal. So in this way you will calculate the numericals. So remember, pressure is equal to force divided area. Now applications. So in everyday life, pressure have the great importance in our life. We know that the tip of a sewing needle is sharp. So since pressure is inversely proportional to the area, so pressure is inversely proportional to area, but directly proportional to force. So a sharp needle puts a large pressure on a very small area of cloth and makes the stitching easy and fast. See here. So sharp needle which have the less area will exert more pressure. That's why when we are sewing the clothes, it becomes easy and fast. Whereas the tires of bigger vehicles such as buses and trucks have broadened double wheels. So this reduces the pressure on the tire and they do not burst. So we know that the wider the area of the contact, the less is the pressure. And so they can transport greater weight. And what about school bags? The school are made thick and wide so that when we are using the bag, so much of books are there. So books create the heavy weight. So more the width, the less weight you will feel. So if the straps of school bags are thick and wide, then our body will feel less pressure because the more area and the thickness is creating less pressure. So for the same reason, the workers carrying heavy loads keep a round cloth on their head as it spread the land over a wide area. This reduces the pressure on the head. See here how the workers use the clothes. Now come to the next page. The foundation of high-rise building. Nowadays, buildings are made wider so that the weight of the building produce less pressure on the ground and the building should not sink into the ground. So that's why nowadays the buildings are made wider so that weight of the building will produce less and the building should not sink. And do you know camel, which is known as the ship of the desert? It is difficult to Camel is known as sheep of the desert. So it is difficult for us to walk on sand. But a camel, though much heavier, can run easily on sand also. This is because a camel has broad feet. So the weight of this camel spread over a large area. So the pressure in the body on the sand is much less as compared to the pressure exerted by us. Walks very easily on sand because they have broad feet. What about the elephant? Elephants are very heavy animals, but still they can walk, they can run. Why? Because their legs are very wide and broad. Their feet are wide and broad, and that's why due to the large area, the pressure, the weight of the elephant does not creates any high pressure. So it creates low pressure. That's why elephant walks very easily and even run. Even the elephant is a heavyweight animal. Now come to the checkpoint. Pressure is the force acting on a area. Acting on a area. The SI unit of pressure is what? Pascal. The SI unit of pressure is Pascal. Number 3, a pointed head exerts more pressure on the ground than the flat heel. Number 4, a camel can run in sand due to its broad feet, broad or wide. Number 5, the foundation of high-rise buildings are made wider to produce less pressure due to the weight of the buildings. And number 6, the pressure is inversely proportional to the area of the base. So that's all for today. So you will write the checkpoint and also do the numericals, and please read and learn the topic. That's all.